Hello everyone. In this video we're going to be solving an interesting differential equation. Why do I call it interesting? Because instead of the first derivative you have the second derivative. So if you had the first derivative, this would be an easy separable equation. For example, if you had y prime equals 1 over 2 times the square root of y, even though there is no x here, which is fine, you could just write write the y prime as dy over dx, and then from here you can put the y's on the same side. So this would be 2 root y dy equals dx, and then you can go ahead and integrate both sides, and then that will be easy to do, right? So, but we don't have that. We don't have the first derivative, we have the second derivative. So what are we supposed to do? So we're going to use a very, very special method. By the way, this is the only method that I can think of. If you know of any other way to solve this problem, please let us know. I'm curious. Great, so let's go ahead and take a look at this problem. When we have the second derivative, but we don't have the first, how do we approach it? That's a good question, right? Now, first of all, notice that on the right-hand side, we have something nice, which you'll see in a little bit why. But since we don't have the first derivative and we do need it, why don't we just introduce that into the equation? So let's go ahead and multiply both sides by y prime. So we're going to multiply by y prime. And then here we have 1 over 2 root y and multiply that by y prime. You could also write it like this, put the y prime here directly, so you don't have to write it as a product. And that's what we have after multiplying, okay? Now, why did we do this? Again, you might be asking this question all the time, but here's what I'm going to tell you first, before you get into the reasoning. When you see y double prime and you don't see y prime, bring it in. Multiply by y prime. You know why? Because it's going to help you. So always do that, and then I'll explain now why it's helpful. So first of all, on the right-hand side, let's focus on this, because this is easier to do. If you think about y prime divided by 2 root y, what does that look like to you? Doesn't that look like the derivative of something? Well, let me tell you. If you differentiate square root of x, you should know this. We get something like 1 over 2 times the square root of x. That's how we differentiate it. Why? Because you can write this as x to the power 1/2. And then when you do the derivative, you're going to bring down the 1/2, reduce the power, and this is what you're going to get. But they are exactly the same thing, right? Of course. But this one is better because here you can see, hey, x should not be 0. What happens if you have like a function of x? Let's say, call that u. If you're trying to differentiate the square root of a function of x, then you also have to, by the chain rule, to bring in the derivative of the inside and multiply by this. And this is what it looks like after you do it. This is exactly what we have, except it's not in u, it's in y. And you're like, why? I don't know, it's given that way. So let's go ahead and do this. This is the derivative of square root of y. You got that? By using the formula and the chain rule, whatever you think it is called, we get that. Nice. So we got the derivative of something on the right-hand side. What about the left-hand side? Okay. Now this might be a little hard to find, but once you know this pattern, you're going to recognize it immediately, and you're not even going to think about it. But let me go ahead and show you. We have the second derivative times the first derivative. For now, and this is not about the equation, just in isolation, let's go ahead and call this u, okay? Then this will become u prime, right? Because the second derivative is the derivative of the first derivative. And since we call this u, this becomes u prime. So we have something like u times u prime. Great, that's better than double prime. Now, how do we approach this? Again, think about it this way. If u was x, you would only have x. So the question is then, x is the derivative of what? In other words, can you integrate x? And the answer is yes, x squared divided by 2. Let's forget the constant or just write it, but this is what I want you to focus on. So instead of differentiating x squared over 2. So in other words, I'm trying to say, if you differentiate x squared over 2, you get x. That's true, right? We don't need a constant. So what happens if you differentiate u squared divided by 2? Yes, you'll do the same thing, but by chain rule, you're also going to multiply by the derivative of the inside, which is u. So u times u prime is the derivative of u squared divided by 2. That's interesting. So we can write this as u squared, the derivative of u squared, divided by 2. Wow. But what is u? U is y prime. So here's what happens. Y double prime times y prime becomes the derivative of y prime squared divided by 2. And when you do the work, you're going to realize that it is, right? Because if you to differentiate y prime squared, you're going to bring the 2 to the front, reduce the power, and multiply by the derivative of the inside, which is y double prime. And then you're going to divide by the constant 2, but the 2's are going to cancel out, leaving you with y prime times y double prime. So, to keep a long story short, this expression is equivalent to that expression. Nice. And on the right-hand side, we have square root of 2, square root of y prime. So let's go ahead and replace this with y prime squared over 2, differentiate it. You can also keep the 2 outside if you want, no big deal. And then we're going to continue from here. Let's go ahead and erase this part. We don't need that anymore, right? Oops. Now we're going to go ahead and just solve it. Well, here's the good thing. You have the derivative on both sides. So you can just integrate. If the derivative of a function equals the derivative of another function, guess what happens? These functions differ by a constant, right? That's my cat in the background, by the way, if you can hear it. Begging for attention, maybe food, who knows? I'll check it out in a little bit. So that's what happens. In this case, the same thing happens. Y prime squared over 2 is equal to the other function plus constant. Nice. You see how things simplify when you know the trick? It's all about tricks, guys. Let's multiply both sides by 2. Y prime squared is equal to 2 root y plus. And by the way, I can just call this c sub 1. It's going to be 2c sub 1 because my goal is to turn it into a c. Since this is a constant, I can call that a c. So y prime squared is going to be 2 root y plus a constant. And now I'm going to go ahead and take the square root. But okay. Now, here's the thing. You can find 2 solutions from here, but I'm going to go with the positive because the other one is going to be super duper simple. Or similar, I mean. Okay? So this is what it comes down to. Wow, that's really cool, isn't it? And you can definitely check your work, differentiate this, find second derivative, and compare it to the original function. But what is y? We haven't found it yet, right? Exactly. So let's go ahead and find y from here. But how do you find y from here? That's a good question, right? So I'm going to show you. This one is a separable equation, and there's no x in it. So this is going to be dy over dx equals square root of 2 root y plus c. By the way, if c is equal to 0, let me tell you that real quick, you get a real simple equation. You get something like this. And guess what? This is super duper easy to solve. Because what happens here is you're going to get something like dy over the square root of 2 root y equals dx. You can integrate both sides, and this is just going to be a power of y times a constant. Easy to integrate, right? But this one is a little tiny bit trickier maybe, okay? Not too bad though. So let's go ahead and do the same thing. Bring the y's together. So it's going to look like this. And then put the x on the right-hand side. So it all comes down to integrating both sides, yeah, right? But to integrate this, on the left-hand side, we have a radical inside the radical. So let's go ahead and call this something. How about calling this a u? 2 root y plus c equals u. From here, 2 root y equals u minus c. And then divide both sides by 2, you're going to get this. And then finally, square both sides. If you square both sides, you get y equals u minus c squared divided by 4. And then from here, you can find dy. Just differentiate both sides with respect to x. If you differentiate this, it's going to be 2 times u minus c. Drop the power. Derivative of u is 1. Actually, we're differentiating with respect to u in this case. Sorry about that, not x. And then that is divided by 4 and du. And now, of course, this is going to cancel out. You're going to end up with something like that. Let's go ahead and make the replacements. dy is going to be replaced with u minus c over 2 du. And that is divided by the square root of u. Okay. In this case, I believe there's a... Wait a minute. That's actually another option that I could probably go off of. Why don't we call the whole thing u? That's probably better, I'm thinking right now. it's probably going to be a better idea because actually, I think this is going to be okay. So can I reverse it? Okay, cool. I can bring it back. I think this is going to be okay, but you can still do the other one if you want. So this is going to be divided by the square root of u. Yep, because I have the square root of something, that should be easy to handle. Now we can kind of write it as 1 over 2. And then inside, actually, we can kind of split it up. But let me write it this way first so you can see what I'm talking about. 1/2 is going to stay outside. And inside, now we can go ahead and separate this as u divided by root 2, which is root u. And then minus c times du over root u, right? Also, you know what? Okay, I should probably do this. Oops. C over root u, and then the whole thing multiplied by du. Here we go. And now we can separate the integrals, of course. But if you think about this, it's if you multiply by 2, it'll make things easier for you because we know the integral of 1 over 2 root u, which is root u. And this one is u to the power 1/2. To integrate it, you're just going to add 1 to it, u to the power 3/2, and divide by 3/2, which will give you 2/3 u to the power 3/2. So it'll look like this, 1/2, and this will be 2/3 u to the power 3/2 minus 2c times root u, okay? And then, of course, there's a plus c in there, but since this is just the left-hand side, on the right-hand side, we're going to have the x plus c anyways. Okay, cool. Now, this is what I have so far, and you can definitely multiply by some stuff. It'll give you 1 over 3 u to the power 3/2 minus c root u equals 2x plus 2c. Basically, I just multiply both sides by 2. Wait a minute, I didn't. I just distributed the number, so it's still going to be x plus c. Never mind. I just distributed the 1/2. So now this is what we have, and you can now back substitute. What is u? What are you? Who are you? Okay, u is the 2 root y plus c. U is 2 root y plus c. So we're going to replace it with 2 root y plus c to the power 3/2, which means you're going to cube this and then square root it. Minus c times the square root of 2 root y plus c. And then that is equal to x plus c. Awesome. Now, if you want to solve for y, I don't think you can. That looks like a cubic equation to me. You probably could call this something, and then you'll get that cube, but it's totally unnecessary. You know, this is basically what it is. But guess what? This is the best part. I'm going to show you what Wolfram Alpha can come up with. All right? So we can compare an LLM and a human being. Ready? Ta-da-da-da. All right, great. I don't know why Wolfram Alpha comes up with something like nonsense. Anyways, this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe. Take care. Don't forget to check out SyberMath and aplusbi. And bye-bye.